Today we're going to talk about error in science. So here we have a little column graph. All of them have their error bars, but you can see poor old little Eric in the middle there. He has a particularly big error bar. So Eric, we just can't trust him. Eric's going to have to go through a series of life lessons in order to be accepted. So how do we reduce error in science, and what types of error exist? Well, here we have Eric. He's managed to go through a series of lessons and he's managed to reduce his error, and you can see his little bar on top there. He's a far happier dude. Alright, there are two types of error that can affect scientific investigations. Alright, systematic error is one, and systematic error can be things like a thermometer that contains small air bubbles that always mean that when you read from the bulk of the thermometer, it's always going to read slightly lower than what it should. Or perhaps you have an old tape measure that has become stretched over time, or maybe it's a really hot day and the tape measure has expanded slightly because it's made of metal. Those sorts of things may be systematic error. You're always going to get a slightly larger reading if your tape measure has expanded, for example, or perhaps you didn't tear your balance properly. So instead of reading from 0.00, it started off reading from 0.01, and that means every measurement you take on that balance is going to be too high by 0.01 of a gram. Or maybe you've got a measuring cylinder and it's got some scummy sand or something stuck in the bottom. You didn't wash it properly and you're trying to measure the volumes of water, so that means every time you measure the volume, it's going to read slightly too high. They're all systematic errors, meaning every single time you do the reading, that's going to be off by the same amount. That is called systematic error. Okay, and sometimes it can be incredibly hard to recognize that you've got systematic error in an experiment. How do we deal with systematic error? So sometimes if the true value, we don't always know what the true value is of a scientific experiment, but systematic error will lead to results that are always off. So you might be highly precise, you might get the same measurements over and over again, but they may be quite a distance away from what the true value should be. So it is really important that we try to minimize our systematic error in an experiment. So here we have Eric, he's looking at that, he's got his concerns. Alright, two types of error. So the second type of error, random error. Random error is a second type of error that affects all experiments to varying degrees. Here we have Eric dropping a little helicopter off a balcony and his brother Errol, who's sitting down the bottom, measuring the helicopter as it hits the ground. Looking at that, immediately you can think that there could be a number of random errors. Random errors, they're not always the same from one test to the other. Sometimes you might measure too long or it might be too short. Okay, so Errol down the bottom here, he might stop the timer too soon before the helicopter hits the ground, or he might stop it too late, well and truly after it's hit the ground. Or perhaps he didn't start the timer exactly when Eric up the top dropped the helicopter. All of those things won't be exactly the same every time the experiment is repeated, therefore they're random. Another example of random error might be something like parallax error. If you were to read the measurement on a measuring cylinder, for example, and one time your head was slightly above the line of sight of the top of the liquid, it might measure too low, and then the other time you might be slightly above or slightly below. So every time it might be slightly different and you're going to end up with what's known as random error again. But overall, it may not, if you repeat your experiment enough times, it may not have too much of an effect. Another example of random error might be if you're trying to measure people's heights. And let's say we've got Eric here, he's measuring his height, and unfortunately this time he slouched, and maybe the next time he was standing upright. So all of these things you can see we can reduce to a degree. but can we completely eliminate them? Well, that is the goal in science, but sometimes it's very hard to completely eliminate random error. So, here we have an example of what random error can do to your results. So here's our true value, and you can see all the collected data points in red around the middle, and you can see that some have been collected at too high due to random error, and others are too low due to random error. But if I was to take the average, where do you think it would sit? Likely it's going to sit in the middle. Now, let's say I only did one repetition of my experiment, and that one result due to random error might be too high, or it may have been too low. As soon as I take two, there's still a chance that they're both too high, or the chance may be both too low, but you can see as I take more and more readings, some might be too high, some might be too low, but they're going to start negating one another. So, how to prevent systematic error? Systematic error. Here we have Eric with his bodgy thermometer with air bubbles, and he's taken a little bit of time. He's collected another thermometer, and he's actually found that when he calibrated his always reads 3 degrees Celsius lower than what it should. Okay, so therefore he can compensate for that systematic error in his data. He actually knows that if his thermometer is reading 33 degrees, it actually means it's 36 degrees because he took this other thermometer and he calibrated his own. Alright, so now that he's done his calibration, you can see that all his data points are sitting far closer to the actual value. Okay, far more precise. I mean, I should say far more accurate, because he had precise data before, and he's still got precise data, but now it's sitting around the true value because he used calibrated equipment. Okay, so to remove systematic error, calibration is a really important part of it. Now, how to prevent random error. Alright, so here we have Errol and Eric again doing a little helicopter experiment, and we can see here there's wind blowing Eric's helicopter away, and Eric's pretty excited by that. Have a look at that baby go. Maybe we should go inside, says Errol. So in they go. They take their whole experiment inside. He finds a little place that he can drop it off, another balcony, an indoor balcony, and Eric has decided, wow, this is much better. The wind's not blowing it crazy all over the place. So he's starting to get far more reliable data. So that's by controlling external variables like wind, you can reduce random error. Again, that's what we strive to do in our experiments. Alright, so here was his initial data. Eric's in there having a look at it. He's not all that stoked with it. You can see there's a really large variance. Okay, so quite distributed, quite spread out. Alright, but he's made his changes, and he's now considered all these external variables, and he's managed to reduce the random error. He hasn't gotten rid of it. There is always going to be some random error. Our job as scientists is to try and get rid of it as much as we can. Alright, he thinks that's a little bit better now. Got a little smile on his face. Alright, but he's got his concerns again. It's still there. He doesn't like it. It's still random error. So how do we get rid of it? Well, like I said, we can't. The only thing you can do to completely negate random error is by repeating your experiment over and over and over again. 3 repetitions is not enough. We want to see you doing minimum of 10 repetitions, but the more the better. In science, sometimes experiments are repeated thousands and thousands of times. Alright, so systematic and random error and how to reduce them. I hope that helped. See you guys.